comment reads, as a Facebook stagehand group reader, I thought that it's not okay to turn chains like that around the batten. At the end of the video, you can see the double bar, the double batten, the truss batten, which is the next line set over, where it's done correctly, indicating it was hung with a batten clamp. We don't determine our safe working practices from group consensus on a Facebook group, on an online forum, on Reddit, on the control booth discussion board. Is that still active? We don't determine safe working practices from these TikTok videos and your comments or my opinions. We determine the safe working practices by looking at the applicable standards and regulations, by determining a safe working load of our components based upon their tensile or breaking strength and their application. A bunch of people's opinions on a forum or a Facebook group about this being not safe is just a bunch of people's opinions. And there was another comment from some folks from the UK or Europe saying, oh, if you choke the chain around that batten like that over here, you're going to get thrown out of our theater. This is not a choke. This is a basket. It's different. This is a basket. This is the same as a lot of baskets that you would do with a span set. If you're going to say this is unsafe, then all of your chokers and baskets that you do with the span set to hang truss, then that should also be unsafe, because this is the exact same thing. Only this isn't a choke, but oftentimes we're choking the span sets. But if we were to do the same exact thing with the span set, wrap it around and do the 2 loops, no one's going to question that with a span set. So why are we questioning it with the chain? A choke is going to be something like this. And I know there are hundreds and hundreds of different methods for attaching your span sets to your truss or whatever equipment you're using. But let's look at the rating of this. Versales, 5-to-1 design factor, V-2RB. Vertical has 5,300 pounds safe working load. A choke has 4,250 pounds safe working load. And the basket has 10,000 pounds safe working load. The basket is almost twice as strong as the choke. I'm not choking here. It's a basket. Here's another span set. Lift all. It's got a serial number that's rubbed off, and it's got a manufacturer number that I think says EM120. And it has a 10,600 pound vertical safe working load, 8,500 pounds choke safe working load, and 21,200 pounds basket application. This is a basket. This is also a basket. This would be a choke. So where do we start? We start with the ANSI standards. The 2016 ANSI standards, I think, is the most recent one. I haven't seen anything new published since then. And what ANSI determined in 2016 is that the batten termination is a dead hung load, and it is allowed to be calculated at a 5-to-1 design factor. This attachment point, whether it's the basket, whether it's the cable to the batten clamp, we are considering that batten termination via a 5-to-1 safety factor. Now you'll notice something interesting with our batten clamps. These J.R. Clancy batten clamps purchased before 2016 say 750 pounds safe working load. It says RWL, recommended working load, but that should be the same thing as safe working load or working load limit, right? The exact same J.R. Clancy batten clamps purchased recently, 1,400 pounds working load limit. What's the difference? There's no difference. The difference is that ANSI has determined that this batten termination can be calculated using a 5-to-1 design factor. So almost all of the reputable batten clamp manufacturers have changed their stamp and their ratings from 750 pounds to 1,400 pounds. Our dynamic load doesn't hit us until we get into this 1/4-inch aircraft cable. The 1/4-inch aircraft cable is the thing moving over the pulley. The attachment point is considered a static termination point. The cable is what's moving. The scenery, that's what's attached to us, is under dynamic load, but the batten termination is not under dynamic load. So now we determine the safe working load of the chain. If it was a single strand of chain, this is 1/4-inch grade 30 proof coil chain, and that has a recommended safe working load usually of 1,250 to 1,300 pounds. We're going to start with that and just say it's a 6,000 pound breaking strength. Some of the manufacturers list the breaking strength, some of them don't. That would be a single strand of chain, 1,200 pounds. And again, because it's 5-to-1, we can use the 1,200 pounds. But because we've created a basket and we now have 2 lines, we have actually actually effectively increased our safe working load of this single piece of chain to 2,500 pounds. So the actual load on this chain on either side is very minimal compared to a single piece of chain because we split it between the two. Our aircraft cable, on the other hand, is 7,000 pounds breaking strength with your NicoPress terminations and your thimbles. And it usually comes with a rating of 1,400 pounds. But that 1,400 pounds is 5-to-1 safety design factor. This is a dynamic load, so we have to use 8-to-1. And I believe that math comes out to around 875 pounds safe working load. So if our single cable, which is our dynamic load, is going to be 875 pounds safe working load, then our goal is for every component below here that attaches to the batten to have a higher safe working load than 875 pounds. If any of these components have a safe working load of under 875 pounds, then our termination is weak. We just determined this chain has 2,500 pounds safe working load. Our shackle is 1/4-inch shackle. Our working load limit of our shackle is 1/2 ton. That's 1,000 pounds. And this one leg of the chain is 1,250 pounds. Everything here is good. Everything here is good. The other question that comes up frequently that is, but this proof coil chain, when you buy it from the manufacturer, it says not for overhead lifting. And again, we're not using it in overhead lifting application here. This termination, this basket is considered a dead hung application. It's not used in overhead lifting because what's meant for overhead lifting, according to the stage rigging handbook, it's meant for chain that is going through a chain motor or through a type of come along or some other mechanical lifting method that is in motion and movement and in a dynamic situation. They do make 1/4-inch chain, grade 80 and some other varieties. SAPSA sells some of this that is rated for overhead lifting if you are concerned about that disclaimer. My caveat is if we know the tensile strength of our device and we have calculated a safe working load that is significantly lower than the tensile strength, if this breaking strength is 6,000 pounds and I've got my load of potentially 875 pounds split on 2 legs to a maximum of 400 pounds each and 430 pounds each, 435, 440 pounds each, 6,000 pounds breaking strength, and I am only going to load it at maximum 400 pounds and 400 pounds. I'm using it in a dead hung application and I'm significantly below the breaking strength. And that is how we determine that this is a safe application. Now you might be saying, well, but it can slide around, it can move around. Yes, that's one of the benefits. It can easily move around. I've got a chalk line from when I just did this a couple months ago. This is where we want it on the chalk line. If it slips around left or right, I can easily put it back into position as well. The batten clamp has a much more fixed and non-mutable position, but the batten clamp requires, as I've said in my other videos, batten clamp and a big 3/8-inch turnbuckle, which puts the top termination point a lot higher here and limits my travel of my line set, which is why I prefer this method. This method has been used for several decades, 3 or 4 decades. It's been in almost every edition of the stage rigging handbook as a accepted and preferred method over the previous, which was the aircraft cable clove hitch and Crosby clamp method. And a lot of people are preferring the batten clamp termination these days, but they're the same. They are absolutely the same for most of our applications for your standard fly rail systems in your standard typical theater situation. So this is all a personal preference if it's done correctly. Batten clamp, 1/4-inch shackle, 3/8-inch turnbuckle, and aircraft cable NicoPress. Almost another foot of height that I've lost in my top travel because I'm using the batten clamp and the turnbuckle. You have to use the 3/8-inch turnbuckle. You can't use anything smaller because of the safe working load of the turnbuckle. And again, the turnbuckle is your termination. You can use the turnbuckle at 5-to-1 design factor. Just like the batten clamp can be 5-to-1 design factor. Believe this is H&H. Yeah, H&H, working load limit, 1,400 pounds, same as the JR Clancy. Again, 875 pounds cable is what our maximum load is going to be on this line in any given application if we're doing our math correctly in our planned rigging. And that means every component here, turnbuckle, shackle, batten clamp, has a higher safe working load or working load limit than our cable. These are interchangeable. And if someone's telling you otherwise, they're full of shit, really. I don't like this method for many reasons, but in actual practice and point of failure and load, this clove hitch is also considered a basket. And if I were using forged clips instead of these malleable clips, this would be an acceptable and safe batten termination option. I just don't like it. I'm not a big fan of Crosby's. The Crosby's are going to reduce my working load limit of my termination and my cable potentially by 85%. 875 pounds times 75% for a 25% reduction would give me around 625 pounds safe working load for this cable termination method at 8-to-1 design factor. Although we all frown on this and we discourage this and we think this is old school and a remnant from the hemp rigging days, when it's done properly, it can be considered a safe method. I'm in the process of taking all of these out of service. I only get a couple of them done a year. I've done more than half of my line sets, so I've got maybe another 20 or so line sets to do, maybe less than that. And again, according to the rigging handbook, the failure point here is not at this point when you're using Crosby's. It's almost always going to be a failure at the top Crosby. That's where your cable is going to break when you do a load test break on it. I would have thought it would have happened down here, but it always happens there.